You were like,
how to
oh, yeah. Mhm. Yeah.
factor when the leading coefficient is not 1. To start this out, we're going to go through both of these other do now problems. Something as a warm-up, but also to illustrate an important idea that definitely will show up on the test. Okay, so first one, we're taking the negative 15 and moving it over. I don't know what people think about this. Is it best if on the board I do the do now problem that you just worked on? Or is it better if I do one from the homework that this is like, that's different from the ones you worked on? The one that we worked on? Okay. We'll try it that way. If people have a feeling that it would be more efficient, that it would be resonate more, we can try it both ways over time. So let's go with this time. Okay. So how do we do it? Well, we got to add 15 to both sides. And everybody, please just really get me through this fast, but with full understanding. So help me out on it. What do I do now? Yeah, Jake. Then add up to? -7. I'm looking for the factors of 12 that add up to -7, right? And at first we were writing all the factors out, kind of laborious process of writing them all out. At some point that becomes too much labor and you start to do it in your head. And I think we're there now, where students are starting to see, oh, well, 7 is like, and 7 is like, you know, a little less than 12, right about the middle. So let me pick the numbers that are close to each other that multiply to give you 12, and that's -3 and -4. And so now you can fill out your template where you have x plus a number times x plus some other number equals 0. And you can put the -3 and the -4 in there, so you get x minus 3 times x minus 4 equals 0. What we have here is we have the product of two numbers. Have you all written the definition of the ZPP? What does ZPP stand for? Zero product property. We've written it before. Can anybody from memory tell me what the zero product property says? Yeah, Sam. If A times B equals 0, the other way around, then what? Then one of the numbers has to be 0. Then either A is 0 or B is 0. Did I actually do this with you? I talked about 15 and I said if Hend and somebody else left the room, I gave them two numbers and they came back in and they said the product of the two numbers was 15. And we said, oh, we don't know anything about the numbers? I can't tell from people's expressions. Okay, so let's imagine we do this. So Adam leaves the room. Bianca leaves the room. I give him a slip of paper. They have these slips of paper. They come back in the room and they say, oh, we saw numbers on the slips of paper, so we found out the product of the numbers. And by the way, while we were out, we threw away the slips of paper. What do we know about their numbers when they tell us the product is 15? Tell me possible values for what the numbers could be to give you a product of 15. Yeah, just shut them out. -3, -5. Say it again. +3 or +5. 1 and 15. -1, -15. Is that the full list? Give me another one. What about 30 times 0.5, 0.5? Oh, that works. Doesn't it? 30 times 0.5? That's going to give me 15. How many are there? Give me another one, just so we can really see this. Let's make this really clear.
2 and 7.5.
2 and 7.5, okay. What about this? Pi. Is there something I can multiply pi by to get 15? What, Alex? There's something, right? Pi is about 3, so this value should be about 5, a little less than 5. But can anybody tell me an expression for the number that I would multiply pi by to get 15? 15 divided by pi? What happens if I multiply pi by 15 divided by pi? The pi's cancel out, we get 15. So now you kind of see, oh my gosh, it could be literally anything on the first slip of paper, and then it would just be 15 divided by that anything for the other slip of paper. So really, we don't know anything about the numbers when they tell us that the product is 15. What if we do the experiment again? Now it's Trisha and Justin, they leave the room, they have their slips of paper, they come back in and they say, ha, the product of our numbers is 0. What do we know? One of them is 0. It's unique to 0. 0 is the only number that works for. Right? There's no way. If the first number is pi, is there anything that I can multiply pi by to get 0? 0. Right? Has to be 0. Okay. What about this -1? Is there anything I can multiply -1 by to get 0? 0. This number is always going to be 0, right? It's not like sometimes -5, sometimes 5, sometimes 15, sometimes 1/2. Right? It's all we're locked down in a way you're not locked down in this situation. That leads to the zero product property, which is why factoring is important. The whole reason we do factoring is because of the zero product property. It will show up on the test. Definitely. Zero product property. Just writing that, being able to write that. X minus 3 times x minus 4, what do we have here? Oh, we have the zero product property. A number times another number is equal to 0. What do we know about those numbers? One of them is 0, thanks Bianca. X minus 3 is 0, or x minus 4 is 0. If x minus 3 was 0, then x would be 3. If x minus 4 was 0, then x would be 4. Okay, how do we do the second problem? Well, really, we're just doing this process in reverse. We're going backwards on this. Starting at the bottom, right? We're saying, okay, x equals 13, x equals -2. Right? What would the corresponding thing to x minus 3 be for x equals 3? For this over here. The x minus 13 equals 0. And for this one? X plus 2 equals 0. Okay, and then what about this? What's the equivalent of this line over in this world? What's the equivalent of this line here where we have the product of two things equals 0? What would be the equivalent of this over in this universe?
X minus 13 times x plus 2 equals 0.
There we go. A quadratic expression with the roots 13 and -2 that you can see. Like if I gave you this and said, what are the solutions to this? Well, you do those steps, right? We're just working those steps backwards. And then how do I get to the standard form? Distribute. FOIL. X times x, x squared. Start doing this in your head. X times 2 is 2x. Minus 13 times x is minus 13x. 2x minus 13x is minus 11x. That's the step, do that step, the outer inner. Instead of writing down 2x and minus 13x, just do that in your head. 2x minus 13x is negative 11x. Negative 13 times 2 is minus 26 equals 0. And we have our quadratic. Are there others? Are there other quadratic expressions, functions that have these as roots? What if I took this and multiplied both sides by 2? Would I change the values down here? No, it'd be the same thing. All right, so 2x squared minus 22x minus 52 also works. Or you might have had negative x squared plus 11x plus 26. Number 3 in not enough time. Somebody slow time. We've got 3.5 minutes. We can get through it. Does anybody have a time slowing device?
Sadly, not yet.
Like one of those phone booths? Wouldn't that be awesome? You just go into the phone booth and okay, that's what you use your phone booth for, right? We have 3.5 minutes left. You use it to get extra time on tests.
I'm going back in time to yesterday.
I use it to sleep more.
That's all you do. Just get more sleep. Or like the what's the spinny thing on the Harry Potter time spinner. Okay, everyone, we're gonna do this problem kind of in hyperspeed, but there's an important thing that I wanted to show you. So, move the 39 over, we already talked about that. 14x squared minus 5x minus 39 equals 0. And now, two different ways to do it. The fast way, honestly, the fastest way is probably just to look at this and say, you know what, this probably has to be a 7 or a 2. It's definitely a 7 or a 2 or a 1 or a 14. Right, and you just kind of use your intuition. This product here, 39, that's pretty close to prime too. There's really only 139 or 3 and 13, right? So you just got to try those different possibilities and kind of work it out using your intuition. Fantastic way, very fast way to factor. I try to make the problems on the test so that way doesn't work very well. So that you have to use this other technique, just because I want to make sure you learn this technique, right? A times C equals 14 times negative 39 is negative 546. And now you're looking for the factors of negative 546 that add up to negative 5. But it's hard because negative 546 is a huge number. Well, here's the trick. Negative 546, if you do a prime factorization on it, is not that many different numbers. It's 2 times 3 times 7 times 13. Right? And once you know that the numbers that go here have to have those prime factors in them. So you're like, 13 times 2 is 26, 3 times 7 is 21. Right? Did everybody just see that? Super fast. Right? There's my factor pair. Those two are close together, right? I want to take the two small numbers and match one up with the big number and the other up because I want to get negative 5 as close to 0, right? So that's a quick way to do that. 26 and 21. One of them negative, one of them positive. That has to be negative. And I think we still have time for me to finish this in flash mode. 26x plus 21x minus 39 equals 0. Take the greatest common factor of the first two terms, which is 2x, leaving 7x minus 13. Do the same thing over here. Take the 7 out, plus 7 times 3x. No, take the 3 out. The 3 out, leaving 7x minus 13. This is repeated. The 7x minus 13, factor that out. 7x minus 13 times 2x plus 3 equals 0. And then you can finish it. And it is now 10:20.
You got a long ahead, he's still going ahead.